In this video, we will be seeing a problem based on ideal effort. Here we have a question. I'll read whatever is given here. In a machine, the effort required to lift a certain load is 150 Newton when efficiency is 65%. Find ideal effort. This is the question which we have. Now whatever is given here, I will write that in the form of data. So let us start this problem by writing the data. This problem belongs to simple machines. In a machine, the effort required to lift a certain load is 150 Newton. Effort is given, so I'll write down P is equal to 150 Newton because effort is denoted by letter P. When efficiency is 65%. Find ideal effort. This is the question. P suffix I is the ideal effort. This much is the data. Now let us try to solve this problem. In solution, since efficiency is given, here I will start with the efficiency part. I'll say that since efficiency of the machine is given by efficiency is equal to the simple formula, it is mechanical advantage upon velocity ratio. So therefore efficiency will be equal to, here for mechanical advantage we know that it is equal to load upon effort into VR. What I have done is simply I have replaced mechanical advantage with the formula of load upon effort, because we know mechanical advantage is the ratio of load upon effort. Now, since I can say that we want ideal effort in this problem, so ideal effort will be there if the machine is ideal, and machine will be ideal if efficiency is 100%, or we can say that mechanical advantage is equal to velocity ratio. This condition needs to be used when the machine is ideal. Now therefore mechanical advantage is load upon effort is equal to velocity ratio. I'll shift P onto the other side, so therefore W upon velocity ratio is equal to P. Here I will put suffix I called as ideal effort. It means the formula of ideal effort is load upon velocity ratio. So here if we see, we are having load and velocity ratio, so I'll say that therefore efficiency is equal to load upon velocity ratio, that is nothing but ideal effort upon P, which is the actual effort. So I can mention, since ideal effort is equal to load upon velocity ratio, so therefore efficiency, it is given as 0.65. Ideal effort is what we have to calculate. Actual effort value is 150. So therefore ideal effort will be equal to 0.65 multiplied by 150. Finally my answer comes out to be 97.5 Newton. This is my answer. And if we see in this problem, they had given the effort, which was the actual effort, efficiency, and the question was to calculate ideal effort. We had used the concept of efficiency, that is efficiency is mechanical advantage upon velocity ratio. From that we have replaced mechanical advantage with load upon effort. Now this value of load upon velocity ratio is nothing but ideal effort. I have explained how this ideal effort formula comes from. So efficiency is ideal effort upon actual effort. I have put all the values and from that I am getting ideal effort. So in this video we have seen how to calculate ideal effort.